All right, trust you did well on your quiz, and students in here did very well on those quizzes themselves. Let's take a look at the homework. Review over, and again, I told you the review today is going to focus mainly on what I cover tomorrow. I feel like everything else in the chapter we really should have done very well. We've kind of continued reviewing it all as we've gone along. We'll touch on some things, but really want to focus on algebraic evaluation, sometimes called numerical substitution, and algebraic representation or translation. Starting with number 1, it says to evaluate if A is 2 and B is 5. What this means, class, is everywhere I see the letter A, I plug in 2. And everywhere I see a B, I plug in 5. And then I do exactly what the problem tells me to do using order of operations. So really, this is order of operations practice. We just have to go and plug a number in for something. And I told you when you plug it in, put the number in parentheses. So when it says A squared plus B, I'm going to make it a 2 squared plus 5. Now, order of operations class says I need to take care of what first?
Exponent.
The exponent. So 2 squared is 4. And then add the 5 to get 9. How many had 9 for number 1? On number 2, it says 3B, but I say 3 times
2.
5.
B is 5. Pay attention. And this says minus A. Well, that means minus 2. Well, algebraic or order of operations says multiply. 3 times 5, class?
15.
Minus 2 is
13.
13. Or you could think of this as 15 negative 2. It's still 13. Look at the next one. Whew, I got a lot going on here. It says AB. Well, that means what times what?
2
Times 5. Okay, then it says plus B squared. Well, that's really
5.
5 squared. And then it says minus B, or minus 5. Or you could think of that as a negative 5. We start with the exponent. 5 squared?
10.
Oh, the pain. 25. There we go. And then here, I can go ahead and do the multiplication also, since this term is separate from this other one anyway. 2 times 5?
10.
That's 10. And then we've got this negative 5. You could either say plus negative 5, or you could just think of it as negative 5. 10 and positive 25? 35. 35 negative 5? 30. How many have 30 for number 3? Look at number 4. It says 8, and then A is 2, B is 5. Plus, it says A squared, so that's 2 squared, negative 3 times, and B is 5. So we plug in all the numbers. So Griffin, we're going to start with the exponent. 2 squared?
4.
That's a positive 4. But we've got these other things that are all multiplied together as separate terms. So let's do 5 times 2
10.
times 8.
80.
Use the commutative property to make the multiplication easier. And then right here, negative 3 times 5.
15. Negative.
Negative 15. Or you could think of it as minus 15. That's fine as well. 80 positive 4.
84.
84. And then negative 15, anyone?
69.
69. Should be 69, our answer there. Questions on 1 through 4? Yes, sir.
So, on 2 through 4, I'll just do 4 as an example.
Okay.
So I put, when it said A and B and 8, I didn't do the times. I put them all together.
You added them.
800.
Oh, no. Okay, so that's why we just covered this initially. 8AB means 8 times A times B, or 8 times A times B, and that's why I told you to use parentheses. Don't just write them in. You've got to put them in parentheses. Does that make sense? That way you know it's multiplication. Not 825, but 8 times 2 times 5, or 80. So we'll practice some more of that in this hour, and we'll make sure we've got it nailed down before tomorrow's test. So in numbers 5 through 8. Oh, any other questions 1 through 4 first? All right. So numbers 5 through 8. One little tricky element, Griffin, that we covered yesterday, and that is the existence of the negative. That's not something we dealt with when we did area formulas, right? And volume formulas. We didn't have to worry about negatives. But they're telling us x is 4 and y is negative 2. So in number 5, it says 3x, so we're going to say 3 times?
Negative 2. No, wait. 3.
X.
4.
4. And then it says plus y. Well, plus.
Negative 2.
Well, what is 3 times 4?
12.
And if we add a negative 2 to that, we get?
10.
10. How many had 10 for number 5? Looking at the next one, it says x squared negative 7y. Well, Griffin, it's not x squared, it's
4 squared.
4 squared. And then not negative 7 times.
Negative 2.
And here's where we got to be careful, class. Of course, 4 squared, Griffin.
16.
16. But negative 7 times negative 2 gives
14.
positive 14, which gives us an answer of 30. How many had 30? How many had 2? If you had 2, you didn't account for the negative. Now, you say, well, Mr. Dasky, can't I think of this as a minus? And so this is 16 minus 7 times negative 2. Sure. What's 7 times negative 2, class?
14.
No, 7 times
Negative
negative 2.
14.
That's negative 14. If you think of this as a minus instead of a negative, it's minus negative 14. But we don't ever subtract, we add the inverse. It still gets you to that point. The easiest way to think of this, though, is x squared negative 7y. 4 squared negative 7 times negative 2 to get the positive 14 that one step quicker. Looking at the next one, it says y squared plus x squared negative xy. Griffin, tell me how to write it down.
Negative 2 squared, 4 squared, minus
Negative.
negative 2, I mean 4 times negative 2.
There we go. Now, negative 2 squared. What does squared mean, class?
Times itself.
Times itself. When you multiply negative 2 times another negative 2, class, what does that give you? Positive 4, not negative 4. So we got to be very careful when you have a negative being raised to a power. It becomes a positive 4. And of course, right here, this becomes positive 16. Careful, 4 squared. 4 times 4 is 16. Then right here, you can either think of this, class, as minus 4 times negative 2. Well, what is 4 times negative 2, class?
Negative 8.
Negative 8. Minus negative 8 becomes plus positive 8 because we add the inverse. Or negative 4 times negative 2, class, becomes positive 8. Either way, right? We end up getting an answer of 28. How many had that? There were some tricky signs in there. How many got the 28? Those who did not, do you see now how to think it through? Again, you didn't get a chance to do very much of this in class yesterday. Not as much as I would have liked. So now's the chance to ask some questions. All right, Griffin, any questions? All right, just be very careful with signs. Look at the next thing. We got an x squared y squared plus 6x negative 6y. How should I set this up? Griffin, I'm going to stay with you.
4 squared, negative 2 squared, 6 times 4, and 6 times negative 2. Negative 6 times negative 2.
There we go. Let's start here. We need to square the 4, Jalen. 16. We need to square the negative 2. We saw this a minute ago, class. When we square negative 2, what do we get? Positive 4. And then those are still up against each other. So, class, those still need to be multiplied. We end up getting a 64 from all of that. This isn't bad at all. 6 times 4, class?
24.
24. And right here, negative 6 times negative 2 gives me positive 12. It's all positivity. And when we add it all together, we end up getting, class? 100. 100, our answer there on number 8. All right, questions on 5 through 8. They're all up on the board now. Questions 5 through 8. Does it make better sense now? Again, even if you struggled in the homework, don't worry about it as long as you look at it now like, oh, okay, I get it now. If you're like, I'm still confused, you better ask questions because we have a test tomorrow. Questions on this. Anyone perfect on 5 through 8? You got all of them? Bryson, good. Joel said sort of. Okay, a few of you. Anyone just miss one? Oh. All right. Let's take a look now at the other part of our lesson yesterday. That was translating words into algebra. And there's a chart, Griffin, on page 133. If you'll glance at it very quickly, you need to memorize what these different words mean. Part of their homework last night was to look over that chart and really make sure they committed to memory these different phrases and what they mean. Most of them are intuitive. As we look back now on page 135, number 9, it says the sum. Well, you got to ask yourself, what does sum, S-U-M, mean, class? Addition, because we know the sum is the answer to an addition problem. So if it says the sum, I know I'm adding some things. What does it say I'm supposed to add, class? 10 and n. So I should write what, Bryson? 10 plus n. How many have that for that first problem, number 9? Look at number 10. It says the difference. Well, class, the difference is the answer to a subtraction problem. So difference means subtract. So if it says the difference of s and t, Luciana, we should write s minus t. How many s minus t? Or s negative t if you want to think of it that way. Look at the next one. Twice the product of a and b. Well, what does twice mean? For instance, if someone is twice as tall as Griffin, Ben's not quite twice as tall. You're tall, but not quite twice as tall. What would twice as tall mean, class? Times 2. Double that, right? Times 2. So we're going to multiply something by 2. So 2 times something. What is the something? Well, then it says the product. Well, class, the product is the answer to a multiplication problem. So if I'm going to multiply a couple things together, what am I supposed to multiply, class? A and B. So I'm supposed to multiply A times B and then multiply that product times 2. Boom. Michael, what's the best way to write this?
2AB.
2AB. How many just had 2AB for your answer? Questions on that one? You see what we're doing here, Griffin? Just asking yourself, what does this mean? So how do I write it? Look at the next one. The quotient of m and n. Well, class, the quotient is the answer to a division problem. Therefore, quotient must mean divide. Now, how do I show division, though, class? As a fraction. With a fraction bar. So when it says the quotient of m and n, Jalen, I should write it
M over N.
m over n. How many had that? Did anyone write m dot bar dot n? It's not wrong, it's just not best. It's not as lazy. All right, m divided by n, or m over n is the best way to write it. Number 13, now here's where we have to do a little bit of thinking. It says to subtract 12 from g. And if you subtract 12 from g, class, that must mean you start with what? G. And from that g that you start with, you subtract away 12. Does that make sense? So therefore, I must first write g and then minus 12, not 12 minus g. Now the book has a little note in there that says that the from means you kind of flip it around. Not always. But I will say this, if you want to write this in the side margin of your book right there, the from comes first. The from comes first. The from comes first. So when they say subtract 12 from g, then we put the g first, because that's the from. Make sense? The reason I say it doesn't mean flip it is, what if they say from 7 take 3? Well, they use the word from. Should I flip it around? No. The from comes first. If they list the from first, then you're good. So anyway, g minus 12. Look at number 14. Says the difference. Ooh, class, what does that mean? Subtract of x and what's the other thing that's being subtracted? The product of 4 and p. So it says difference. So class, I know I'm going to subtract, and there's two things. Now the first thing in this difference is x. It says the difference of x and, but they don't just give me one thing. They say the product of 4 and p. What does product mean?
Multiply.
So I need to show 4 and p being multiplied in the second part of the subtraction problem, class.
4p.
Did anyone have x minus 4p? That was a hard one. The difference of x and the product of 4 and p. Questions on that one? All right, we're going to look at more of these, don't worry. Look at the next one. 9 less than the ratio of x and 2. Now, less than, class. What does less than mean? Subtract. But I had them write this in their notes yesterday. The word than, T-H-A-N, means, class, flip it. So, when it says less than, class, we know that means
Flip it or subtract.
subtract. But instead of 9 less than something, the than means flip. So instead of the 9 going first, it's listed first. But I actually write it behind the minus sign. 9 less than something means something minus 9. And then what is it 9 less than? Well, it says the ratio of x and 2. Corey, what does ratio mean? It has the idea of division, because ratio has the idea of a fraction. Fraction means division. So there's going to be some ratio, and then we're going to subtract away 9 from that. 9 less than the ratio of, Corey?
X and 2.
So I'm going to put,
X over 2.
how many got x over 2 minus 9? How many forgot to flip it? You had 9 minus the x over 2? All right. How many just forgot what ratio meant? You forgot it meant division. You put something here, but maybe it was like a 2x or something. All right, questions on that? Looking at the next one. The sum of C and D. Well, again, class, sum means addition. So, Griffin, how would I write the sum of C and D?
C plus D.
C plus D. How many had that last one? Give us a nice easy one there at the end. Let's take a look at the rest of the problems on here. Number 17, what did you get for your answer, Ben?
5.
5. Number 18, Kirsten.
23.
23. Number 19, Joel.
Number 23.
Number 19, what did you get?
Negative 30.
Negative 30. Number 20, what did you get? Elaine.
73.
Keep the sign of the greater.
Negative 73.
Negative 73. There we go. Number 21, Bryson.
30.
Positive 30 when we add the inverse. Number 22, Luciana.
Negative 3.
Careful. It's already addition. Don't change it to adding the inverse, right? It already is addition and the signs are the same. So we add and keep the sign to get
Negative 29.
negative 29. Do you see that? Now, number 23, that is subtraction. So we do add the inverse, Corey, to get
65.
positive 65. And the number 24, again, that one is subtraction. So we do add the inverse to get what, Jalen?
0.8.
Positive 0.8. Questions on the homework? Questions on the homework? Flip over to page 137, if you would, please. Flip over to page 137. On page 137, I want you to practice with some more of these evaluation things. Look at this, the number 56 to 69 in your books. Do you see the little section there that has 56 to 69 in it? Notice it says right above that section, a little blue shady thing. Evaluate each algebraic expression when x is 3, y is negative 1, z is 4. You might want to draw a little box around those little values there. X is 3, y is negative 1, z is 4. Just help catch your eye, because you're going to keep looking back up at that box over and over again, as you do. 56 to 68, just the evens. 56 to 68, do just the even numbered problems. Use parentheses as you plug in the values and follow order of operations. Let's see how we do. You broke your pencil. Use a different pencil. Or do that. If you finish early on the evens, go back and do the odds. If you're still working, that's okay. about 30 seconds long. We're going to be finishing up and working the evens, 56 to 68. Pencils down. Even if you're not finished with all of these yet, here's what I'm going to do. I'm going to go through and give you the answers. If you got them all right, we're good. Whichever ones you missed, ask a question. All right? Number 56, 15. Number 58, 2. Number 60, 4. Number 62, 0. Number 64, 24. Number 66, 4. And number 68, fun with the fraction, but not too bad if you're careful, 14. All right, first question, was anyone perfect? Anyone perfect on the several of you? Okay, now, does anyone need to see number 56? You missed 56. Okay, got a couple of you. So the key here is write 3 times, and instead of x, put 3, and then plus 6. What do I have to do right here, Ben?
Multiply.
To get?
9.
9. And then 9 plus 6 is 15. Looking at number 58, does anyone need to see 58? Okay, Luciana, we've got 2 times, and it says y, but that's -1. It says plus z, so that's plus 4. We need to multiply. What is 2 times -1? -2, and then I'm adding a 4. Well, since the signs are different, we're going to subtract, keep the sign of the greater absolute value. That's where we get the positive 2. Does that make sense? How about number 60? Anyone need to see 60? We've got a 3 times x, which is 3. Then it says plus y, which is -1. And it says minus z, which is 4. Or we could think of this as a -4. We start with 3 times 3, Joel. 9. And then we've got this -1. And then we've also got a -4. Or you could think of this as plus -4. Either way, we've got 2 negatives. -1, -4 gives us -5. And then we put that with the +9, and that's where we get the +4 from. Does that make sense? All right, anyone need to see, let's see, we're on number 62. Need to see 62. We've got 2 times x, which is 3, plus 6 times y, which is -1. Then what do we get for 2 times 3? 6. And then what about positive 6 times -1?
5.
Then we're multiplying. When we multiply, we say, are the signs the same or different?
Different.
We automatically get a
Negative.
negative. Now, what's 6 times 1?
6.
6. So that gives us -6. Well, this is a positive 6. And if we have a positive 6 and we add a -6 to it, they cancel. And we're left with 0 because, class, what do we call these numbers?
Additive inverse.
Additive inverses. Does that make sense now? Okay? So yeah, remember, make sure we multiply things up against each other instead of trying to add them. It sounds like you were trying to add to get a 5 right there. Looking at number 64. Anyone need to see 64? Got a couple of you there. We've got 4x, which is 3, plus 4y, which is -1, plus 4 times z, which is 4. So, Jalen, what is 4 times 3? 12. What about 4 times -1?
-4.
And 4 times 4?
16.
Now, keep in mind, these are positives. That's the only negative. So let's get the positives together, Kirsten.
28.
Positive 28. And then we'll put the -4 with that, Corey, to get positive 24. Does that make sense? All right, how about number 66? Anybody need to see 66? All right, so we've got an x, which is 3, plus, and it says y squared, that's -1 squared. Now, Corey, -1 squared literally means what?
-1 times -1.
And what do we get when we multiply a negative times a negative?
A positive.
Positive, and 1 times 1 is?
1.
So this all becomes a positive 1 right there. And of course, this is just a 3. And so positive 3, positive 1, there's our positive 4. All right, and then number 68. Anybody need to see 68? All right, so we've got a 2/3 x. And of course, x is 3. And it says plus 3 times z, which is 4. Now, I gave you a strategy tip yesterday, class. If you're multiplying something by a fraction, put it over 1. And now the 3 and the 3, one's a numerator, one's a denominator class.
Cancel.
Cancel. So right here, all I've got is a 2. And then of course 3 times 4, Corey. 12, and then the 2 plus 12, that's where we get 14. All right, questions, comments on those? Does that help? Feel like we understand them better now. We may come back and look at the odds if we have time, but for now I want you to flip the page. Do numbers 1 through 10. Flip the page. I want you to do numbers 1 through 10 in the homework section, top of page 138. Page 138 at the top in the homework section. Do numbers 1 through 10. Several people finishing up. Take just a little bit longer at your seats to be finishing up. It's purple. It's light purple and white.
Oh, I can't see it.
It's a lavender.
There's a lavender and a white kind of mixed, real small pattern in it. It's okay.
Oh, I see. Is it that?
No, it's not. It looks white.
I don't know. Anyway,
It just looks white.
it's okay. Let's take a look at these together. Number 1, in the expression, by the way, how would we read the expression in number 1, Jalen?
Negative 8y squared positive 2z.
Great job. Negative 8y squared positive 2z. It says, number 1, identify the variables. Well, what are the variables in that expression, Kirsten?
Y and z.
Y and z. Then it says, identify the numerical coefficients. What are those, Ben?
8 and 2.
Careful, it's not actually an 8. What kind of 8 is it?
Negative 8.
Good, it's a negative 8. The sign matters, right? That's a big part of it. So negative 8 and positive 2. And then it says, identify the exponents. What are the exponents here, Joel?
Y over 2 over y, or
So the 2 is an exponent. It's the exponent of the y. What's the exponent of the z?
1.
A 1. Because if there is no exponent written, class, it's an understood
One.
1. What if there were a 0 power? You'd have to see it, by the way. You could never have an understood 0 power. Anything to the 0 power equals 1. Let's see. Then it says number 2. Write that group of factors as one single algebraic term. Corey?
9a squared b squared c.
Great job. How many had 9a squared b squared c? Number 3. What type of polynomial is that thing, Ben?
Trinomial.
Trinomial, very good. Number 4, how would we write this as an algebraic expression? The product of 12 and b exceeded by 5. Got a brave volunteer back there, Elaine.
12b plus 5.
How many had 12b plus 5? It says the product of 12 and b. So we know we're going to multiply 12 and b, which means mush them together, 12b. Exceeded by means to go beyond, to add on to something. Exceeded by or plus 5. Great job. Let's drop down to numbers 5 through 10, see how we did on these. It says a times b decreased by 20. Well, let's not make this too hard. How do I write a times b, Griffin?
AB.
AB. And then it says decreased by 20. Now, Griffin, you haven't seen this one yet, but what do you think decreased by means?
Subtracting.
So subtract. So we would say
Minus 20.
minus 20. How many had AB minus 20? Number 6, the ratio of 6 and R increased by C. Oh, they haven't talked about this one yet. You won't have this on the test, by the way. This says is 11. Well, the ratio of R and 6. Let's start there, Michael.
R over 6.
R over 6. And then it says increased by C.
Plus c
Plus C. And then it says is 11.
equals 11.
Equals 11. How many figured out that the word is means equals? Again, you're not going to have that on a quiz or test yet, but that's something we'll talk about later. Anytime you see the word is or the word was in general, forgive me here, linking verbs. Linking. Have you ever noticed, by the way, how you mark your verb? You always put 2 lines under it. You know why? Because the verb in most mathematical statements is an equal sign. Yeah, so you're really drawing an equal sign under your verb because this equals that, right? And you've even talked about that with linking verbs, right? If I say, Griffin is my favorite student. Griffin is or equals student. I'm just as an example sentence, of course. But, well, he was going to be my favorite student. He skipped out of my class yesterday. There goes that. Got to pick a new game. Anyway, but is or equals, right? This equals that with the predicate nominative. So anyway, again, you don't have to know that yet. Number 7. Y decreased by X. Luciana?
So y minus x.
Y minus X. Very good. 10 divided by S. Bryson. Number 8.
10 over S.
10 over S. Good. Show the division with a fraction bar. Number 9. The product of 2 and X. Ben.
2 times x.
How do we say 2 times X?
2.x.
2 raised dot X? We could, but there's a better way. Be lazy.
2x.
2X. There we go. Mush it together. Be lazy. Number 10. The product. Ooh, this is a tough one. The product of 7 and T exceeded by the product of 2 and W.
Zaki,
Yes, ma'am.
can
You need
send
Griffin?
Down to the office. His mom is here.
All right, we'll send him down.
No more favorite.
There goes favorite student status again. Leaving my class early. All right. The product of 7. Oh, yeah. Kirsten, you were raising your hand there. How would we say the product of 7 and T, first of all?
7t.
7T, not 70 like the number or the old age. Just 7T. I'm not there yet, by the way. Somebody made jokes yesterday. Anyway, exceeded by,
Plus, or
yeah, and then the product of 2 and W.
2w.
Did anyone else have 7T plus 2W? Great job. Questions on that? All right, let's look. Where are we? Page 140. Flip over a couple pages. Page 140.
Oh.
And let's take a look at numbers 58. Drop all the way down to number 58. There's an old style desk right there at the top of the page. Page 140, number 58. At your seats, figure out the common difference on 58. Figure out the common difference. They're coming out and telling you it's an arithmetic sequence. They need you to tell them what the common difference is. Bryson? Well, 13 is the next term, but what's the common difference that told you it was 13? 2, right? The thing that gets added or subtracted if it's a negative, the thing that gets added is the common difference. So we're adding a 2. The next term is 13. Number 59, this one's a little bit tricky. What's the common ratio? Again, they're telling you it's a geometric sequence, but what is the common ratio?
Oh.
Joel?
-3.
Good. How many had -3? Good. Notice the signs are bouncing back and forth. That means it's got to be a negative. And obviously the easiest 2 to look at is 3 and 9. Well, how do you go from a 3 to a 9? Multiply by 3. How do you go from 3 to -9? Multiply by -3. Number 60. They want you to actually write out the first 4 terms of an arithmetic sequence. They're telling you the first term, so you actually only need the next 3. They're telling you the common difference is 7. Get the first 4 terms. If the first term's 8 and the common difference is -7. And Ben, what you got? What do you get if you add -7?
1.
And then if you add another -7,
-6.
and then you add another -7.
-13.
There we go. How many had 1, -6, and -13 as the next 3 terms? Number 61. First 4 terms of a geometric sequence. First term's 24. Common ratio is 1/2. Ooh. First term's 24. Common ratio is 1/2. And let's go to Michael. Michael, what you got?
24, 12, 6, 3.
Good. What would the next term be, anybody?
1/3.
1.5. 1 and 1/2.
1.5 or 3/2 if you were to keep going, but they stopped it right. Just multiply by 1/2. Over and over again. Number 62, class. In that expression, what's the constant term?
20.
Positive 20. Good, Jalen. 20 is the constant term. What would we call 6x and -5y? Those would be called variable terms because they have variables in them. Number 63, bless you. How many terms are in that expression, Elaine?
4.
4. Number 64, what are the factors in the expression 11x squared y? What are the factors? Again, things being multiplied. Luciana?
11 x squared and y.
Good, 11, x squared, and y. Or if you said 11x, x, and y, you wouldn't be wrong there either. Number 65, let's rewrite that. The easiest, nicest way is a nice, easy term. Bryson? 5d cubed z squared. Number 66, what is w to the 0 power equal to, class?
1.
1. Number 67, how would we write the product of x and y as an algebraic expression? Jalen? xy. Number 68, write a increased by 12 as an algebraic expression. Ben? A increased by 12.
What number was it?
It's the last one, number 68. Pay attention.
60?
On number 68,
Oh.
it says write A increased by 12. Sorry, I thought you had this done already. A increased by 12 as an algebraic expression. What does increased by mean?
Times.
It's a multiple. If we increase something. If you were to increase your height by 2 more inches, you'd be obscenely tall. But if you were to increase your height by 2 more inches, does that mean we multiply you by 2 more inches? No. We just add on 2 more inches. So increased by means add. So A increased by 12 would be?
A plus 12.
A plus 12. Good. Top of the next page. Write the difference of 7 and G as an algebraic expression. The difference of 7 and G as an algebraic expression. And what we thinking there, Joel?
7 minus 2.
7 minus G. Number 70. take a moment. In fact, do 70 and 71 now. They've given you what A and B are equal to for 70. They've given you what M and W are equal to in 71. Follow order of operations. All right, looks like most of us are done. Check your work. Did you at least get yourself some partial credit on the test tomorrow if this were a test problem and plug in the numbers? If you'll start with that, two things. Number one, you're less likely to screw something up. Number two, you get partial credit if you do screw something up. So show me plugging in the numbers. Now, what is, well, notice these terms are all separated anyway. Technically, I guess we should start here, but they're all separated. So we can do 3 times 3 first. 9. That wasn't bad. Now right here, I look at this as -5 times 3 times -2. If there are 2 negatives in this grouping of multiplication, 2 negatives is even, right? That gives me a positive. 5 times 2 times 3, 30. You could think of this as -30, and minus -30 would give you plus positive 30. Either way you want to go. Right here, -2 squared, we've seen this a few times now, means -2 times -2, class?
Positive 4.
That's positive 4. 9, positive 30, positive 4 gives us 43. How many had 43? Okay, questions? Questions on that one? Let's look at the next one. We have MW -4M negative, quantity 3 plus W. Now we do need to start with these parentheses here because there's inside 3 plus 4, class? 7. So all of this just becomes a 7 right there. Now right here I've got to multiply. -5 times positive 4, class? -20. Read this as -4 times -5, class? Positive 20. Or if you say 4 times -5 is -20, it's minus -20, which still gives you positive 20. But do it the lazy way, in my opinion. And then over here, you can either think of this as -7 or -7. If you think of it as -7, you have to add the inverse, and you still get a -7 right there. But what happens with -20 and positive 20, class?
0.
So my answer is just
-7.
-7. How many -7? 4, number 71. Questions on this? Questions on this? Look, if you would, we don't have time to do all of them, but look at the section on page 140. Numbers 40 to 57. We had to skip over these. It wouldn't be a bad idea to practice over those just for extra practice sake. I'm not going to give you all the answers right now, but if you got some practice, you're going to have a lot of those. A big section on your test, because one of the most important things we've talked about is sign numbers. Being comfortable with positives and negatives. Another thing that wasn't in our review today, but you need to make sure you know it, commutative property means change the order. Associative property, change the grouping. And distributive property is the one where you multiply to everything that was added or subtracted in parentheses. Remember, what 2 processes are commutative? Addition and multiplication. What 2 processes are associative? Addition and multiplication. But in the distributive property, you have to have something multiplied. What's the only stuff that can be in the parentheses? Addition and subtraction have to be in the parentheses. Then you distribute to everything there. Because what you really need, and we didn't teach it this way because you didn't know this yet, you have to have separate terms in parentheses in order to distribute. You distribute every term. We didn't know what a term was yet, but that's how that one works. I think other than that, we've covered everything for your test in our next lesson, lesson 104. No written homework tonight. Skim through chapter 3, look over example problems, make sure you're ready to go. Make sure, especially if that translation stuff has been problematic for you, page 133, table A, look it over. All right, have a wonderful rest of your day. You are dismissed.